So in our previous videos, we learned about congruence of triangles. In this video tutorial, let's focus on criteria for congruence of triangles. What do we mean by that? Let's understand. Suppose we have this triangle and it's a white triangle and it's physically in your hand. And we have another triangle of pink color. It's also physically in your hand. Now, if you're asked whether the two triangles that you're having in your hands are congruent or not, that is, whether they are of same size and shape or not, what you will do is, let's say that you will take this triangle and you will try to place this triangle over the white triangle, and if these two triangles are of the same size and shape, then they will cover each other completely. That is, if this pink one will fall exactly over the white one, and in this case it happened. Okay, so yes, these two triangles are congruent. Like we can see here, the pink one has completely covered the white one. Okay, that means that these two triangles are congruent. This was the case when these two triangles were physically in your hand. What if the condition is something different? What if this information is given to you? This is one pair, this is another pair. If you look at these two triangles, ABC is an equilateral triangle with sides 5 cm. PQR is another equilateral triangle but with sides 6 cm each. Therefore, these two triangles are not of same size and shape, that is, they are not congruent. What about this pair? Now, in this triangle ABC and PQR, all the sides are of 6 cm. So since the sides are of 6 cm each, both these two triangles are equilateral triangle, and yes, they are of same size and shape. Therefore, these two are congruent. But there can be some situations where you will not be having complete information like these, and then it will be asked to you to tell whether the triangles are congruent or not. What do we mean? Suppose we are dealing with some situations where only some information is missing, like this one, it's missing. Okay, and then you have to tell whether the triangles are, suppose these angles are missing, let's suppose, and then you have to tell whether these two triangles are congruent or not. Now, of course, you're not having these two triangles physically in your hand, so there is no way that you can place this one over this one. That's what we deal in criteria for congruence of triangles. Let's understand that. What do we mean by it? Suppose your friend asks that, can you draw a triangle if I give some information to you? Okay, can you draw that exact triangle if I give some limited information to you? You will say that, okay, let me try, give me the information. Your friend says that one side of the triangle should be 4 cm. You will say, okay, if one side of the triangle is 4 cm, let me draw this here. Let's say I draw this line and it represents 4 cm. So your friend says that, okay, go on. You will say that there is no way I can proceed further, because if I have been given only this information, then there is no way that I can draw the other sides. I don't know about the length, I don't know about the angles and all, right? Okay. Your friend says that if this is 4 cm, let me give you another information that the another side is actually 5 cm. So you will say that, okay, the other side is 5 cm, but you know what? I still can't draw. So your friend will ask it, why? You will say that, you know what? I can draw 5 cm like this, that is a right angle. Okay, I can draw the 5 cm like this, like this, like this, like this. Okay, so I don't know whether it's an acute angle, it's at a right angle, or it's an obtuse angle. I don't know, so I can't tell about this. Okay, your friend says that's fine. So 4 cm is given to you, 5 cm has also been told to you. Now your friend says that even if you can't even draw after these two after this information, that is two sides are 4 centimeter and 5 centimeter, then let me tell you the third side. The third side is actually 7 centimeter. You will say, that's the correct information you have given to me. So you'll say that what I will do is, I'll take this point, from this point, I'll draw an arc of 7 centimeter. I'll draw an arc of radius 7 centimeter, something like this. You drew an arc of 7 centimeter. Okay. Now from this point, at the end point of this side, I'll draw a radius of 5 centimeter. So let's say that you draw a radius of 5 centimeter, an arc of radius 5 centimeter. Okay, so this one was for 7 centimeter and this one was for 5 centimeter. Now you can see it has these two arcs intersect each other here. Now if we join this triangle like this and like this, so now this is 7 centimeter and this is 5 centimeter. Now your friend says that, hey, that's really very nice. You know what? This was my triangle and it's what I was asking for. Okay, so 7 centimeter, 7 centimeter, 4 centimeter and 4 centimeter, 5 centimeter and 5 centimeter, right? Let's name it. If I name it as, let's say, R, Q and P. So this is triangle ABC. This is triangle ABC and this is triangle PQR, right? So in this case we can clearly see that since we can easily draw an exact triangle like this one if we are given the 3 sides. Initially it was given only one side, that was not possible. Then it was given the second side also, it was also not possible. Then finally your friend gave you the third side, then you can draw an exact triangle like this. Therefore you will say that triangle ABC is congruent to triangle ABC and triangle PQR are congruent, right? So these two triangles are congruent. Now you will say that, hey, you know what, it's 7 centimeter here, it's 7 centimeter here, it's 5 here, but 5 is here, and 4 is here and 4 is here. Don't worry, we know that we can set the correspondence. Two triangles are congruent always under a correspondence. What do we mean by that? We have to find the corresponding vertices and the corresponding sides. That's really very simple. In this case, if you see here, this is AB and this is AB is 4 centimeter and in this case RQ is 4 centimeter. Okay. Now some may think that, you know what, this is triangle ABC is congruent to triangle PQR. That's why let's say that A and P are corresponding vertices, then B and Q are corresponding vertices, and then C and R are corresponding vertices. What do we mean by that? What that person mean by that? That person means that if we place this point vertex P over A, Q over B and R over C, then we'll get exactly, this triangle will exactly cover this one. No, that's not the way. Here this triangle ABC and triangle PQ are simply representing these two triangles. They are not defining the correspondence. Okay, it can be, but they are not exactly defining. Like in this case you can clearly see that, like in this triangle 7 centimeter is here, but in this one 7 centimeter is here. So we have to tell the corresponding vertices, and that's why let's do it how you'll do here. Now this AB is equal to RQ is 4 centimeter. Then if you see here, we have BC and PR or RP, anything, PR as 7 centimeter, and then we have CA or AC. We know that CA can be written as AC also. CA is equal to PQ equal to 5 centimeter. Okay, now let's try to find out the corresponding vertices. Take this AB and this CA. Why? Because A vertex is coming in both these two. Okay, so if I take AB is equal to RQ and CA or AC is equal to PQ. Now you can clearly see that AB is equal to RQ, CA is equal to PQ. This Q is common in both these two. What it means? This Q is common in both these two. That's why this Q is actually the corresponding vertex of A. It's corresponding vertex of A, right? AB is equal to RQ, CA is equal to PQ. Q is present in both these two situations. It means that Q is actually belonging to A. That's why it's here. Therefore, you'll say that A and Q are corresponding vertices. Now, since in this case Q is corresponding vertex for A, therefore it means that R and B are corresponding vertices, right? So B and R are corresponding vertices, and from here we can say that P and C are corresponding vertices. So C and P are corresponding vertices. Therefore, when you place this triangle over this one, Q will come here on A, R will come on B, and P will come on C, right? So like you'll rotate it and then you'll put over it, then the vertex Q will fall over A, R will fall on B, and P will fall on C. So the correspondence is ABC QRP. This is the correspondence under which these two triangles are congruent. So this is really very important point. Okay, so it means that if you are given side and side, okay, if you're given side of a triangle, that if three sides of one triangle is equal to three sides of another triangle, it means that both the triangles are congruent. And in short, we say it SSS criterion. Right? By knowing three sides, we can exactly draw a triangle. It means that if we know three sides, that is three sides of one triangle is equal to another three sides, or to three sides of another triangle, both the triangles are of same size and shape, that is they are congruent. Okay, so this was about SSS criterion. SSS criterion, right? Three sides are equal of two triangles, both are congruent. Let's move to another criterion. So another criterion is something like, your friend says that one side is 7 centimeter, let's say. Okay, one side is again 7 centimeter. You'll say, okay, one side is 7 centimeter. And he says that, he or she says that the next information is that the angle from this side, this is 7 centimeter, the angle from this side is, let's say, 120 degree. That is the angle, this side includes that angle. Okay, so we'll say that 120 degree. Let us draw from this point. If I draw an angle of 120 degree from this point, right? So let's say that this goes our triangle. Okay, this is 120 degree. Okay, So your friend gave you this angle as 120 degree. You'll say that that's not sufficient information. Your friend will say, why? I have already given you one side and one angle. You'll say that it's okay, you have given me one angle, but I don't know where this line will end, right? Where this will go, because it has no length. No length has been given for this one. So your friends will say that yes, exactly, that's good point. Okay, assume that this is only 3 centimeter. It's only 3 centimeter. So you'll say that okay, 3 centimeter. From this point, you'll draw an arc of radius 3 centimeter. Let's say you draw an arc of 3 centimeter and that intersects at this point. Okay, so this is now 3 centimeter. You'll say your friend, thanks a lot dear, you gave me a side, then an angle, and then another side. You know what, now the triangle can be easily drawn. Your friend will say how? You'll say that I know this endpoint, I know this endpoint, and let me join them. So if we join it, here you have the triangle. It means that if one side, an angle, and another side, that is two sides, and the including angle, this angle is including angle, that is this angle is in between these two sides. If such condition is given to you, that is SAS is given to you, side angle side, this one, then angle this one, and then side, that is this one. So SAS, that is side angle side criterion, is this thing only, that if two triangles are there, let's say triangle ABC and triangle PQR, if two triangles are there such that the two sides and the including angles are equal, two sides and the including angle are equal, then these two triangles will be congruent. Why? Because you can draw exactly a triangle like the previous one by only having this information, that side, angle, and side. Okay, now let's discuss that your friend says that, you know what, I'm giving you two angles, angle and angle. Okay, these two angles are such that they are on a common side, so your friend says that okay, assume that it's actually 120 degree and 120 degree, and it's, let's say that it is 60 degree. Suppose, not exactly, but 60 degree. Sorry, not 60, it can't be 60. Let's say it is some 40 degree. Okay, now you will say that okay, you have given me simply this information and these two angles are present on the same line. Let me draw this. Suppose my line is something like this. Okay, now you'll think that I don't know the length of this line. I can draw these two angles maybe here, maybe here. I don't know exactly where should I begin with, because I don't know the length of this line. I can even start from here also and can draw 120 degree. I can start from here also. So there is no way that I can exactly know what will be the length of this side and where should I start drawing these angles from. And that's a really very good point. And you tell this problem to your friend. Your friend says that, hey, that's a really very good point actually. So your friend says that okay, what you can do is assume that this is of length 5 centimeter. You will say that thank you very much. Now you have length of this side, that is including side, of say 5 centimeter. So from here to here, from point A to point B, you have now 5 centimeter. Okay, now you have these angles 120 degree and 40 degree. So you draw 120 degree from here. Okay, so you draw 120 degree from here. So angle A is 120 degree. You draw from here, you draw something like this. We don't know the length, don't worry, right? Now you know that this angle is actually what? 40 degree. So you say that very simple. Let me draw a 40 degree angle from this point. So if I draw from this point, let's say that it goes all the way like this. Sorry, it's not a straight line. It goes something like this. Now we have this intersection here. This is C. Now we have a triangle here. This was 120 degree, this was 40 degree, and this side was given to us. It was 5 centimeter. Now you can clearly see that if angle, the including side, and the another angle, this angle including side and this another angle on the same side, so it means that this side is actually including side of these angles. If this information is given to you, that is angle, side, angle, angle, side, angle, if it's only this much information is known to you, then you can draw an exact criterion. You can draw an exact triangle which is being asked for. It means that you can draw a congruent triangle. This triangle ABC is exactly congruent to the triangle that your friend is asking for. What information was given to you? Initially, he gave you only 120 degree and 40 degree, but you were not knowing the length of this side. That's why you said that I need some more information. Then your friend gave you this length of this side. You say that that's now thank you, because from this point I can draw 120 degree. Even you can begin from here also, okay, but it was your choice. You started from here and then you drew 40 degree from here. The intersection point is here. Now you know the third vertex, that's ABC, right? So ASA criterion, angle, and the including side, angle, side, angle criterion. If this condition is being satisfied, that is the two triangles are having two angles and the including side equal, then the two triangles are congruent. Okay, what about your friend says that, you know what, now you have to draw a right angle triangle. You'll say that, your friend will say that you have to draw a right angle triangle and it should be congruent to mine. You'll say that, okay, thank you for giving me the information. You'll say that, let me quickly draw a right angle triangle. Okay, you drew something like this. Your friend says that, okay, proceed. You'll say that there's no way I can proceed. I have only this much information that the triangle you are asking for is right angle and I have drawn here, but what else? So your friend says that, okay, if this is right angle, the hypotenuse, that is the largest side, the hypotenuse is, let's say, 10 centimeter. It's 10 centimeter. Okay, now your friend asks to, draw. You'll say that it's still not possible. Your friend will ask why. You'll say that because I can draw 10 centimeter like this. I can draw 10 centimeter like this. I can draw 10 centimeter like this. Your friend will say that yes, exactly. That's a good point. So your friend says that hypotenuse is 10 centimeter and one of these sides is actually, let's say 8 centimeter. You'll say that thanks a lot, now you have solved my problem. You'll say that, okay, let me assume that from this point to this point is actually, from here to here is actually 8 centimeter, right? This is a right angle triangle. The length given to us is actually what? 10 centimeter. I'll start from here, and from this point I'll draw a 10 centimeter line to this point, right? So from here I have one endpoint. Of course, if I know one endpoint, then my 10 centimeter will surely go and intersect at only one given point. There can't be more than one point now, because we have one endpoint, that's here. So this line segment will only intersect at one single point, okay, not more than one point. So let's say that it intersects here, right? So this is A, this is B, and this is C. What was initially given to us? A right angle, right? So it was not sufficient. Then your friend gave you this hypotenuse, length of hypotenuse. Even that was not sufficient to you, okay? Now even that was not sufficient to you. Then you asked for another information, and your friend told that one of these sides is actually 8 centimeter. Now it's not exactly it's not an exact diagram like this is 10 centimeter, but maybe it would be intersecting somewhere on the upper portion, okay? It's not exact figure, just to explain you that what do we mean by this RHS criterion, okay? What do we mean by this RHS criterion? So right angle was given to you, then hypotenuse was given to you, and then one side was given to you. On the basis of that, you can easily draw, on the basis of that you drew a triangle that your friend was asking for, and it's exactly the same triangle. That is, if two triangles are such that, if two triangles are right angle triangle and the hypotenuse, the length of the hypotenuse are same and two sides are same, okay, so hypotenuse are same and the sides are same, then the two triangles will be said to be congruent, and this is RHS criterion. R means right angle triangle, right angle, hypotenuse, and one of the sides. So RHS criterion. So what all we learned? We learned side criterion, that is two triangles having three sides equal are congruent. Then we learn side angle side, that is two sides and an including angle. If two triangles are same, then the two triangles are congruent. Then we learned about angle side angle, that is two angles and the including side. Two angles and the including side, the common side to both these two angles. If two triangles have the same values, then the two triangles will be said to be congruent. And then we have right angle, hypotenuse, side. If two triangles are right angle triangle having same length of hypotenuse and sides are also of same length, one side is of same length in both the two triangles, then this criterion will tell you that the two triangles are actually congruent, okay? Right angle, hypotenuse, and one side.